Hi, I'm Rita Pucci from the Department of Mathematics, Computer Science and Physics at University of Udine. I'm here to present to you fixed simplex coordinates for angular modulus in CapsNet. First concept that we want to talk about is an embedding. What is an embedding? Embedding is a mapping of a discrete categorical variables to a vector of continuous number. This concept in neural network means reduce the dimensionality of categorical variables, maintaining a meaningful representation of categories in a transformed space, like shown in the image top right. This can be approached with the CNN-driven approach. We can obtain embedding by taking the intermediate output of a considered architecture, so the output of an intermediate level of CNN. Between the CNN approach models, we identify CapsNet. What if we apply CapsNet as deep neural network encoder to extract the embedding? CapsNet produces an output that is a matrix, digit caps, that we use to compute the embedding of image. But let's take an overview of CapsNet. CapsNet is a model composed by convolutions, a convolutional layer, initial convolutional layer, and capsules layers. Capsules are a group of neurons that generating activity vector are specialized to identify entities inside images. This structure produces digit caps. Digit caps is a matrix X that is n vectors d-dimensional for capsules, computed by capsules, where n is the number of classes. We compute the image embedding by computing the magnitude of each row of the matrix X, and we obtain hat X. Hat X maintains all the information from the digits at each capsule and provides discriminative embedding based on the predicted class. This image embedding is used to train the model to enhance the intra-class compactness and inter-class discrepancies among images. A common approach for this is using softmax function. Softmax function denotes the probability of X being classified as class C, but does not encourage the similarity among intra-class samples and the diversity among inter-class samples. For obtaining these features, we apply angular modulus, and we train the model with angular modulus. Angular modulus reduces the geodesic distance between the image embedding X and the vector centroids WC of the corresponding class C. So as shown in the figure, we want to push the vector hat X to be as similar as possible to WC. And to do so, we reduce the angle between the two vectors in the loss function. The model trained with this loss function we call polyCapsNet, and is a variation of CapsNet with maximal discriminativity. But the angular modulus introduced the need for a weight matrix W to represent the class centroids described in the hypersphere of definition. To have this matrix, we want to define this matrix fixed, to use a fixed classifier, because a fixed classifier can guarantee stationarity of the embedding. To decide how to define this matrix, we use polytopes. Polytopes are geometric objects with flat sides, and the vertices of polytopes are used as vectors of the matrix to obtain maximal discriminativity representation. This concept was proposed by Pernici in fixed for features. So we bring this concept of polytopes for a fixed weight matrix to our variation of CapsNet, and we add another loss function to the original two loss functions, reconstruction function, margin loss function, and also now we have angle loss function. So the final loss is the combination of the three losses. The result obtained with three losses are explained in this table. We tried our model trained with angular margin loss over 3 benchmarks, NIST, Cipher10, and small knob. We obtained good results with all the 3 datasets, but in particular with NIST and small knob. That means that the information provided by the angular margin loss makes the model polyCapsNet in this case understand better the relative entity features that are presented in the image. But what if instead of a fixed classifier we use a learnable classifier? So we try a learnable classifier, but as we see in the table, the bottom side, the results are absolutely better when the classifier is fixed. If you have any question, thank you, ask me. Thank you for listening.